Alrighty. So we're going to go through this factoring practice, and I tried to pick questions that are very factorable, very doable, but also made sure that I made notes about them. So this first one we already did in our warm-up. This is part of our warm-up. So you guys already have this. You're just going to write down your answers. This first one we did in our warm-up. And I think it was the first question of our warm-up. So you're just going to copy the answer from your warm-up. This is an example of what happens when A equals 1. And we used this whole times plus box. And to get that, you take A times C, and it has to add up to B. That's the method for that, okay? What about example number 2? Do you see anything unique about number 2? It has a GCF. What is the GCF? Yeah, this has a GCF of y. So that means that I can take a y out of both terms. So I'm going to divide both terms by y. And when I do that, I have y on the outside. What is y squared divided by y, Seamus? Y squared divided by y. It's y. And a negative 36y divided by y, Tiana. Negative 36y divided by y is negative 36. And that's it. That's as factorable as that can get. You can't do anything else with that. That is factored completely. So that's a really good example of when you only can take out a GCF, right? You can only take out a GCF. Okay. Example number 3 has a GCF. And the GCF is 3, actually. So it has a GCF of 3. And once we take that out, it becomes an A equals 1 type of trinomial. So the first thing I'm going to do is divide every single term by 3. And remember when you do that to put your 3 down at the bottom, right? And I know I'm going to end up with 2 binomials because this is a trinomial, so I can write it as a product of 2 binomials. So when I factor a 3 out of that entire trinomial, what do I have left? Yeah, I have x squared plus 5x plus 4. And so now since A equals 1, remember the factors that you choose are the factors that you use. 2 numbers that multiply to 4 that add up to 5. 1 and 4. So this factors out to x plus 1 and x plus 4. And that's it. Are you guys remembering this stuff? It's coming back to you? Yeah? Thanks, Ashton. What about example number 4? What kind of problem is that? It's only 2 terms. Say it again. It's dots. Yeah, this is a difference of 2 squares. We call it, the like acronym for that is dots, right? Oops, my pen died. Yeah. That's a great question. Number 2 has 2 variables. Do you see that there's a variable on each term? Number 4 does not. Okay. And that's a good idea. So you know, because there's a variable in each term, you know that there's got to be a GCF, and you know that this binomial right here in number 2, this grouping, isn't factorable anymore because it's not the difference of 2 squares. Remember, if you only have 2 terms, it's either factorable by a GCF or difference of 2 squares. Well, y minus 36 is not 2 perfect squares. It would have to be y squared. and they don't contain a GCF. So that's how you know it's done. You are so welcome. That's such a good question. So we know that number 4 is factorable because both of those are perfect squares. And that was your dark pink sheet, and I'll get your journals graded and back to you. So let's see. I want to do the square root of m squared. What numbers do I multiply together to get m squared? Yeah, m times m, right? So we're just going to write it just like that. M times m. What is the square root? We did it like this when we did this lesson. What is the square root of 144? What number do I multiply by itself to get 144? 12. And again, that's on your little perfect square sheet. So what do I put in between the parentheses for those two binomials? One of them gets a plus and one of them gets a minus. Does it matter if I put the plus first and the minus second? Can I change it and write it as m minus 12, m plus 12? Yeah, the order does not matter. Okay, and that's it. That's what difference of two squares looks like. Let's go to number 5. Let's go to number 5. What kind of problem is number 5? Does it have a GCF? Oh, who said that? I heard someone say something. Jaden, what was it? Yeah, this is a difference of two squares, and here's how you recognize this. 16 is a perfect square. A squared is also a perfect square, and 49 is a perfect square. The square root of 16 is 4. The square root of a squared is a, and the square root of 49 is 7. So you write this as 4a plus 7 times 4a minus 7. Remember, I'm going to put a little note here. The perfect squares must be joined by a minus sign. It's got to be a difference, a minus. Can we factor the sum of two perfect squares? So we actually wrote a note about that in our journal. Can we? We cannot. Okay, we cannot. I want to jump down to number 10 because it looks hideous. We're going to do number 10 and number 12 together. And then we're going to go to the next page. Let's do number 10 and number 12. What is going on here? Yeah, do we like fractions? No, we do not like fractions. So what do you think that we can do here? Don't be discouraged by the fraction. Think about the rule. Don't be discouraged by the fraction. Think about the rule, or think about what you know. And you know that if you have two terms, if you only have two terms, two things happen. You either look for a GCF or you can factor it using the difference of two squares. Or both, right? You could have both, but you have to start there. Two terms. So, has a GCF of n. Good job, Violet. So Violet says, hey, it has a GCF, and that GCF is n. So we're going to divide both of our terms by n. Drive it down. Don't forget about it, right? We're going to hopefully be able to factor this as a perfect square, like two binomials. So when I take an n out of this first grouping, 9n cubed divided by 9n to the first leaves me with what, Uriah? Hang on a second. Hang on. Think about your exponent rule. If the base is the same and you're dividing, what do you do with your exponents? You subtract. So what is 3 minus 1? Okay. And is anything happening to the 9? Are we dividing that by anything? No. So it's going to be 9 times n to the what power? Good job. And then when I take negative 4 over 49 divide to the n divided by n, what happens there? The n goes away. Perfect. Okay, so now we just have to ask ourselves, is 9n squared a perfect square? Is that on our little pink list of perfect squares? Yeah, it is. Okay. What about 4 over 49? We didn't do fractions, but can we break it up? Is 4 a perfect square? Yeah. Is 49 a perfect square? Okay. So I think that that's a fraction made by multiplying two like the same term together, right? So let's do our little square root sign. So the square root of 9n squared is what? 3n. So I'm going to put a 3n in the first parenthesis and a 3n in the second parenthesis. We're going to break this fraction up just like we talked about it. We're going to write it as the square root of the numerator and then the square root of the denominator. Okay. So what is the square root of 4? 2. And what is the square root of 49? Oh my goodness. So I'm going to put a 2/7 and a 2/7. Now what? Plus and a minus. Good job. Plus and a minus. And that's it. That was a tough one. We haven't worked with fractions, right? Because we typically don't factor with fractions. Okay. I think I told you I was going to do number 12 with you, right? Okay. Ashton, 12 is tricky. I want you to take a look at it. It only has 2 terms, just like the one above it. So let's think about if we have 2 terms, what did we say? What are we looking for? 2 terms. And then what? Perfect. So do you see a GCF in there, Ashton? Y? What's the smallest y power that they both have? So y squared. Okay, good job, sir. Do you see a number that divides both 18 and 12? Okay. Does anybody see anything else? 6. Are those both divisible by 6? Yeah. So I think 6y squared is our GCF. So let's take that out first and see if then we end up with the difference of 2 squares. We're just doing it a piece at a time. So let's see. Matthew, when I divide 18y squared by 6y squared, what do I have left? 3. Good job, sir. Bailey, when I divide 12y cubed by 6y squared, what do I have left? What is 12 divided by 6? You're close. 2y. Good job. A positive 2y. I know what you did. That's perfect. Okay. Is 3 plus 2y a difference of 2 squares? Can we use the dots method for that? No. So are we done? We are done with that one. Okay. Flip it over to the next page. Flip it over to the next page. So which one of those did we do in our warm-up? Which one of those did we do in our warm-up? Do you guys see it? Yeah, number 13 was one of your warm-up questions. This was your warm-up. So this one is already done for you. And this was an A does not equal 1. And we used both the box method and the slide and divide with this, right? We did both. So you're just going to write your answer. You don't have to use both methods. Just choose one of those methods and fill that in, okay, when you do that one. Let's look at number 14. Let's look at number 14. So what kind of problem is this? Does A equal 1? What do you think, Carla? Does A equal 1? No. So what method do you want to use? Do you want to use the box? You want to use slide and divide? Okay. So I'm going to write that off to the side. Slide and divide. Carla, do you feel like you're a pro on that? You can walk us through it? Go for it, girl. Perfect. So I have x squared minus 11x plus 30. So Carla, I'm looking for two numbers that multiply together to give me 30, that when I add them, I get negative 11. Two numbers that multiply together to give me 30, that when I add them, I get negative 11. This one's Carla, no shout outs. Since your product is positive and your sum is negative, that means both your factors are going to be negative, right? So go to the negative side of your table. How are we doing this in our calculator? What do we type in? Y equals what? 30 divided by x. Y equals 30 divided by x. And then what? Then what do? Second graph. Go to the negative side of your table. You're looking for two numbers that when you add them together, you get a sum of negative 11. What are your two numbers? Yes, ma'am. Your two factors are going to be negative 6 and negative 5. Your two factors are negative 6 and negative 5. So what do I do with those? I write this as what, Noah? X minus 6 and x minus 5, because the factors that you choose are the factors that you use, right? Now, what's the divide part, Carla? Because we haven't done that yet. We divide. We have to divide both of our factors by 2. Divide both of our factors by 2. Carla, what is negative 6 divided by 2? So that first factor becomes x minus 3. What is negative 5 divided by 2? Does that divide nicely? So what do I have to do with that 2? Put it in front of the x. Good job. 2x minus 5. That is slide and divide. Okay, I want to do number 17 and 19 with you. 17 and 19. And then you can pick one more from that page that you think is going to be rough. Are we ready for 17? Okay. All right. Jaden, going to you. What do you think? It's a trinomial. Has a GCF. Yeah, it does. What is the GCF? Does every single term contain a GCF? Does every term have a Y on it? No. But there is a GCF here. What can you tell me about all of the numbers? The coefficients, 14, 46, and 12. Yeah, they're all even. That means they're all divisible by 2. So I think that they all have a GCF of 2, right? So we're going to start with that. We're going to divide everything by 2. What do I do with my GCF? Drive it down. Yeah. Okay. Jaden, 14y squared divided by 2 is? Perfect. 46y divided by 2 is? 23y. And a positive 12 divided by 2 is? Okay. What method do you want to use to solve this? Because this is an a does not equal 1. Slide and divide. Okay, walk me through it. Is? Yep. So I have y squared plus 23y plus 42. So Jaden, you're looking for two numbers that multiply together to 42, that when you add them, you get 23. Two numbers that multiply together to give you 42, that when you add them, you get 23. 2 and 21. Good job. Good job. So A is 1. When we do that slide and divide method, the factors that we choose are the factors we use. So we have y plus 2 times y plus 21. So we've taken care of the slide part. What about the divide part, Jaden? What did we slide? What did we do? We slid the 7, so we have to divide by the 7. So does 2 divide nicely by 7? So what do I do to that? Yeah, so 7y plus 2. What about 21? Does 21 divide by 7 nicely? Yeah? I heard someone say, yeah. What is that? 3. Y plus 3. So final answer, 2, the GCF that we took out originally, times the quantity, 7y plus 2, times the quantity, y plus 3. That was a tough one. That was a tough one because we had a GCF. Are we good? Yeah. Okay, Tayana, I'm coming to you. Number 19. Tell me about number 19. What do you see? Does it have a GCF? Let's see. Factors of 25 are just 5 and 25, right? 5, 1, 25. So look at the smallest number, right? You always start with the smallest number. Factors of 4 are 1 and 4 or 2. So 25 is not divisible by 4 and it's not divisible by 2, so we don't have a GCF. Okay. So does A equal 1? No. So what method do you want to use? Do you want to use the box or do you want to use slide and divide? Slide and divide. Okay. You're up, girl. What do I do first? You got it. $25 times 4. So that gives me x squared minus 20x plus 100. Okay. So I'm looking for two numbers that multiply to 100, but when I add them, I get a negative 20. Remember, if your product is positive and your sum is negative, that means both your factors have to be negative. So you're looking at the negative side of your table, Tiana. Negative side. Yeah. Yeah. Right on the money. Page 20. Good job. Good job. Perfect. Have you found them yet? Okay. Go to the negative numbers. Negatives. Go up, 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 up. There you go. Keep going. Whoops. What do you have right there? What happens when you add those two numbers together? Oh, what is it? Yeah, negative 10 and negative 10. So that becomes x minus 10 times x minus 10. Zan, is there a better way to write that? Are we okay with writing it like that, or what's the preferred method? You are. Yeah, divide both of them by 25. So this one is challenging because we can't just slide that 25 out front. It'll give us a GCF. What do we have to do with our fraction first? Reduce it. Yeah. Calculators, 10 divided by 25, give me the best reduced fraction for that. 10 divided by 25, give me the best reduced fraction. What is it? Yeah, 2/5. Okay, so I have x minus 2/5 times x minus 2/5. Is that an acceptable answer? Who said no? Tiana, was that you? Why? What do I want to do? I want to put the 5 in front of the x. I do. So I want to write it as 5x minus 2 times 5x minus 2. And then there's one last thing that I'd really like us to do. Perfect. Yeah, we want to write this as parenthesis 5x minus 2, close your parentheses, squared. Perfect, perfect. Okay, I want you to pick one more from that page. One more from that page that you want me to do. 24, you think that one looks scary, Ashton? I'm down with it if you're done with it. So do you want me to do 22 instead? Okay. How about if we do 22 and then we talk about 24? Okay, I'm going to write a little note that says talk about, because I think that you're scaring yourself by the size of your exponents. So let's do 22 together. Ashton, you're in charge on this one. You're in charge. So I'm going to start you off with Ashton. Is there a GCF? What is it? You're right. There is. Is 44 divisible by 8? Okay. So there is a number that divides all of them together. What do you know about all those numbers? Look at that. 44, 38, 8. They're all what type of numbers? They're evens or odds? They're evens. So if all those numbers are evens, that means they're divisible by what? 2. So we're going to divide every single term by 2. Let's do that. We're going to take out a GCF of 2 first. Thank you, sir. Perfect. So when I take that 2 out, I'm going to drive it down to the bottom. 44x squared divided by 2 is what, Ashton? That's all right. 44x squared divided by 2 is what? 20. You're right. 22x squared. Negative 38x divided by 2 is? Perfect. Negative 19x. Good job. And positive 8 divided by 2 is? 4. Okay. So does A equal 1? Is my leading coefficient 1? 22 equals 1? No. A does not equal 1. So what is that method you want to use? Slide and divide. Okay, you're in charge. Slide it first. So when we slide, we're actually multiplying. So you're going to take 22 times 4. Good job. X squared minus 19x plus 88. So Ashton, you are looking for two numbers in your calculator that multiply to 88, that when you add them, you get a negative 19. So remember, if your product, that top number, the 88, if that's positive and your sum is negative, that means both your factors are going to be negative. Got it? Okay. So y equals 88 divided by x. Go to the negative side of your table. You guys should all be looking for this. This is not just Ashton's job. You guys should all be picking up your calculators. Negative 11 and negative 8. Good job. X minus 11 times x minus 8. Are we done? No, we did the slide part. What do we have to do now? The divide part. What am I going to divide both my factors by? 22. We have to divide both of these by 22. Okay. So I would use my calculator, right? Because we want to put those as simplified fractions. So someone needs to figure out what 11 divided by 22 is as a fraction, and someone needs to figure out what 8 divided by 22 is as a fraction. How do I get a fraction? How do I get a fraction from a decimal? Refresh my memory. How do I get a fraction from a decimal in my calculator? Well, I divide. Then so like if you take 8 divided by 22, you're going to get a decimal. How do I turn that answer into a fraction? Math 1. Math 1 says, hey, do you want your answer to be a fraction? So what do you get? What is 11 divided by 22? I just heard you say it, Noah. So this is x minus 1/2. And then what is 8 divided by 22 as a simplified fraction? Yeah, x minus 4 over 11. Are we leaving those fractions in our answer? No, we are not. What are we doing with those denominators? Yeah, put them in front of your x. Put them in front of your x. So final answer. Violet, final answer. Whoa, what'd you take out originally? And say it loud so everyone can hear you. Perfect. Violet said 2, and then she said parentheses 2x minus 1, close your parentheses, and then she said 11x minus 4. A lot of steps there. All right. We're going to talk about number 24 because it was making Ashton nervous, right? So it's making you nervous because of this, Ashton, I think. Am I right? Because it has to the power of 4 and to the power of 2. So you factor it the exact same way. So you're still going to do your slide. So it's going to be x to the 4th minus 17x squared plus 16. So you're still looking for two numbers that multiply together to give you 16, that when you add them, you get negative 17. The only difference is, Ashton, when you set up your parentheses, you actually have x squared at the front instead of x, right? Because x squared times x squared is going to give you your x to the 4th. Yeah, absolutely. Does everybody see that? Does that make sense? Write that down really fast. That's your number 24. That's how you're going to get that set up. And then I'm going to go back up to 14. Okay, so here's 14, Noah. All right, I'm going to do one of the groupings. I'll do one of the groupings with you. You tell me which one you want me to do. You're welcome, sir. I'll do one of the groupings. On the next 2 pages. So which one do you want to see? They're all pretty straightforward. Don't let 31 and 32 mess you up with just those extra variables. None of them have a GCF that you need to pull out at the very beginning. So which one do you want to do? 25 through 32. Pick one. I'll do whichever one you want. Going once. Delilah, you choose. Oh, what'd you say? 28. Okay. So can I put you in charge of it, Noah? Do you remember how to group? Okay. So how about if I help you out? What do you start off with? Divide it up into two what? Yeah, two groups. All you're going to do is divide it up into two groups. So that's what we're going to start with. So my first binomial and my second binomial. All right, Delilah, I want you to look at this first binomial. And is there a variable? Let's first of all talk about the variable. What is the smallest variable that both of those terms share? Yeah, x squared. Good job. Kimber, I want you to look at that same binomial. And is there a number that divides both 3 and 21? Is there a number that divides both 3 and 21? 3. Yeah, good job. So we're going to take a 3x squared out of both of those terms. Bailey, I want you to look at the second binomial, confer with Cameron, and tell me what's the GCF of that second one. Good job. Okay. So I'm taking a 3x squared out of my first one. Noah, when I divide 3x cubed by 3x squared, notice that my 3's cancel out. And if I use the rule on this one, what do I get? Yep. 3 minus 2 is, you just get x. Good job. And then go to the second one because you were right. The x squareds cancel out, so I just get 7. Perfect. You are confident on this. Doing great. I'm going to bring out my plus 2 that I'm taking out of the second term. So Noah, when I cancel out a 2 from the top and the bottom, what do I have left? X. And negative 14 divided by 2 is? Good job. Negative 7. Do I have the twin that I'm looking for? Do I have that repeated factor? I do. So GCF plus GCF, that's the 3x squared plus 2. That's the terms that we took out of them originally, multiplied by your twin. GCF multiplied by the twin. That was number 28. Okay, I'm going to do 2 more with you, and then you guys are going to be on your own. 2 more. I want to do number 33 with you. And I want to do number 38 because it looks crazy. You were going to ask for that one? Yeah, how many terms does number 38 have, Noah? Yeah, we don't know how to factor 6 terms, so there's got to be a trick in there. Okay, so let's start with number 33. I think 33 is going to be a tricky one. I think 33 might be a tricky one. So, how many terms are there? 2. 2 terms. What do I always look for first? Second? You guys are on it. GCF and dots. 2 terms. Okay. So, is there a GCF? X? Is there something else? 3. Who said that? Was that you, Kimber? Yeah, GCF, 3x. So when I take my 3x out, remember to put it down in the very bottom. Let's see, 3x to the 5th divided by 3x to the 1st leaves me with what? X to what power? To the 4th, yeah. Negative 48x divided by 3x leaves me with what? Negative 16. Okay. So we've done the GCF. Now we need to check for the dots. Is x to the 4th power a perfect square? It is. Remember that variables are perfect squares. I'm just going to write perf, and I'm going to use the square sign. They're perfect squares if the exponent is, I'm going to write positive. That's not true. If the exponent is even, meaning it's divisible by 2. If the exponent is even, it's divisible by 2. And 4 is divisible by 2, right? So we're going to use the dots method. Let's see. What is the square root of x to the 4th? X squared. And what is the square root of 16? It's 4. So I have x squared plus 4 and x squared minus 4. But I think this is a tricky one. This is why I wanted to do this. Why is this tricky? You can find the square root again of what factor? Which one? The one that's the last one, yeah, the very last one, because it's joined by a minus. Okay, so you can do dots again right here. You can do dots again. So 3x times the sum of two squares, that cannot be factored, x squared plus 4. But what is the square root of x squared? X. And what is the square root of 4? 2. What do I put in the middle of those? Plus and minus. Okay. Do you guys feel all right with that one?
Yeah.
Okay. Ashton, I love it that you are always positive about your answers. Last one we're going to do is 38. And then you guys are on your own. We're going to do 38 together. And 38 has 6 terms currently. I want everyone to look at number 38. So, Travis, when you look at number 38, what do you see that you could do with it before you even try to factor it? Think about the most basic idea of polynomials. And I'm going to write this off to the side. Combine like terms. Do you see anything in there, Travis, that you can group together because they have the same variable to the same power? Awesome. Hang on, let me underline those with squigglies. Okay, and what else? Perfect, Travis. Good job. So that x cubed can't be grouped with anything. We're just going to bring it straight down. But 5x squared plus 4x squared is what, Travis? 5x squared plus 4x squared is? Awesome. And 6x plus 20x is what, Travis? Awesome. And then our last term is that positive 24. Okay. Think you can factor this by grouping? Do you think so? Okay, we'll try it. We're going to try to factor it by grouping. So, what's the greatest common factor I can take out of my first binomial? X squared. When I take an x squared out of my first term, I'm left with x plus 9. What's the greatest common factor I can take out of my second grouping? A 2. When I take out a positive 2, I'm left with 13x plus 12. Do we have a copycat? No, we don't. What does that mean? It means that we can't factor it. This is only combined like terms. That's all you can do here. This polynomial cannot be factored using methods that you know. So this stays just what we had originally, x cubed plus 9x squared plus 26x plus 24. Will someone let Gianna in? I'm glad you asked about that one. That was tricky. Okay, so you guys have the rest.